Hello and welcome to another member sponsor video. Hosting Mr. Logan Frank. Continuing on with our little mini series over how to create Pong with Python. So here we are with part 4. Logan, what you got planned in this video?
Well, I think in this video we're going to cover the players.
Okay.
We're going to make a player class so that we can handle the player-specific aspect of making sure that the player paddles do not go off screen. Once we have those player classes, we'll make 2 players, one for player 1 on the left side of the screen, one on the right side of the screen. And then we'll move on to the update method. Okay. Inside of the update method, we're going to start worrying about input handling. So we'll get specific keys for each player, make sure that the paddles can be moved, and we'll also deal with collision detection between the paddles and the ball to make sure that whenever the ball hits the paddle, it gets reflected off. And we'll also make sure that velocity is imparted to the ball based on the spin percentage value.
Gotcha. So by the end of this video, we're going to have the game pretty much functioning other than some score in place.
Yep, we will.
Okay, awesome.
So, to begin, we need to implement a player class. So I'm going to scroll down here just under the ball class, and we'll make a class for player. Now, player is also going to extend actor, because we still want to leverage things like velocity, position, texture, and so on. Now, inside of the player class, the first thing that we're going to do is we're going to have a score that is held within the player. And right off the bat, we're going to set that to a value of 0. And we'll get back to the scoring more. Again, I'm just going to drop that in ahead of time since it's very simple, and we'll worry about that more in the next video. But just players have a score, just like everything else has things like position and so on.
Okay.
So, and the next thing I'm going to do is inside of the player, I'm going to override the move function. I need to specify some things in addition to simply moving, and those things will be limiting the paddle's movement to lock them on screen. So, we'll define a move method. Move is going to require, or is going to look at the current instance, and it is going to require an amount, a move amount, to be fed to it. The very first thing it's going to do is make sure it calls actor.move for the given amount, so we get the base functionality in place. And then right after that, let's see, we need to so actor.move amount. Actually, inside of the move, we need to specify the instance before we feed that back up to actor.
Okay.
Once we've got that in place, we'll go ahead right here and do the checks. And those checks are to make sure that the paddle hasn't gone off the top of the screen and also that the paddle hasn't gone off the bottom of the screen. If it has, we're simply going to snap its position to move it back on screen. So the first check is if self.position.y is less than 0. So if the top of the paddle has gone off screen. If that is the case, then we need to snap it back to 0. So self.position.y will be set to 0. Now, if we haven't gone off the top of the screen, we still need to check and see if we've gone off the bottom of the screen. So we'll do an elif the self.position.y has gone past the bottom of the screen. Now, the position y rests at the top of the paddle, so we actually need to take the overall height into account as an offset. So if the position y has gone past the screen height, and then we'll subtract back the height of the actor itself. So self.texture.getRect.height. And fix a little spelling. And if that is indeed the case, then we need to snap to the bottom of the screen. And that is self.position.y is set to the screen height, the bottom of the screen, offset by however high the actor is. To do that, we've already figured out what that value is, so I'll simply copy and paste that expression in place. And then we have the correct value to lock ourselves to.
Excellent.
And with the else if, actually let me bring that back a space. So we have our tabbing set up. And with that now, that is all I wanted to cover inside of the player class. Really the only thing unique to it is the fact that players store a score value and that they are locked to the screen. So, what I want to do now is create the actual player 1 and player 2 variables. So I'll create some new players down here. I'll jump down to the game objects section. We'll begin with player 1. The player 1 is going to be equal to a new instance of player. Player is an actor, so it is going to require a texture upon creation. So we'll feed in player texture. Again, that being the paddle file that we loaded above. And let's see, some things we need to do to the player. We want to make sure that it's offset a little bit off the edge of the screen.
Off the left-hand side.
Exactly. And I'm pausing just for a moment because it might be nice to show this. Before I worry about the actual positioning, to see this positioned, I could go into the draw method, and we could set up draw to be able to draw player 1.
Okay.
So right after we blit the texture, the ball texture to the screen, we could then turn around and do the same thing for the player texture. And just to save time, since it's the same call, I'm going to copy and paste our call to blit, and we'll only change ball to player 1. So we have player 1's texture and also player 1's get bounds method, that's called. So now I believe if we run and we don't have any syntax errors, then we get the result. We can see this paddle up in the top left-hand corner of the screen, and that is the expected result because its position is at 0, 0, and no offsets have been done to it.
You can see how it's also hugging that left edge as well.
Exactly. And we had specified a paddle offset. If I scroll back up to the top of the code now, we have this paddle offset value, just so we'd have some amount that we could space the paddles off the edge of the screen. So if I scroll back down now to the game object section, we can use that here by setting player 1's position in X equal to the paddle offset value. So now we're spaced off the edge of the screen. The next thing that we want to do is make sure that our paddles are centered in the Y direction, so they're centered on the screen. So to do that, we'll jump in here and tell player 1 to center on Y.
And get the yell out.
And
change that to an N.
Center. Yes.
Perfect. Okay. And there we go.
Now we have the paddles centered on the screen in Y, but offset a little bit in X. And you'll also note there is no further functionality for collisions as the ball just passed right through the paddle. So let's see. Probably the next thing we want to do is make the other player. So we've got that's working good for player 1. I'll copy all 3 of those lines, paste them in directly below, and we'll name this variable player 2. We'll use the same paddle texture, but now X needs to be the other side of the screen minus the width of the actor and then minus that offset to get offset in the other direction.
Right.
So X is going to need to be equal to screen width minus the width of the actor. So that would be, let's see, quickest way to get access to that would probably be to look at the bounds. So player 2 dot get bounds dot width. And then from that we could further subtract the paddle offset. And we're still going to center in Y. And now if we run, we get nothing. Why do we get nothing?
Make sure that we're drawing the other guy.
Exactly. We have not added a line that will blit player 2 to the screen. So once again, we can go to the draw function, copy and paste screen.blit, change this over to player2.texture and player2.getBounds. And look at that, player 2 now resides on the other side of the screen.
Nice.
So all is working very well. Of course, at the moment, if you were to try to use any keys to move the paddles, nothing would happen. We're not handling input for the players yet. So, I think it's time to go ahead and jump into update and do just that.
Okay.
It's inside of the update function that we're actually going to look for player input for the paddles. And this might seem a little bit odd at first because we had done some work with keys down here in our main game loop. We had looked for a key down event and then checked to see if that was escape. Instead of doing the key input here, I'm actually going to do the input inside of update because I'm going to get the input in a different manner. The reason I'm going to do this is because I don't want to use the event-based key down style event.
Gotcha.
What that would do would make it would only detect the key down one time, and then the key would have to be released and then pressed again to get another key down event, which means we'd only be able to move our paddles in one increment segment, so we'd have to keep releasing the key and pressing it over and over again. The effect I'd like to get is that as long as the key is held down, the paddle continues to move. So that means we're actually going to need to get key state, not a key event. So back here in update, right after I've decided what the time factor is going to be, I'm going to get the key input. And PyGame has a get keys.getPressed, which will get the state of all of the keys. So I'm going to make a keys variable. We'll set that equal to pygame.key.getPressed. And what this is going to do is it's going to return a sequence based on every key. So the overall number of elements in this should be equal to the number of keys that PyGame recognizes. And the way they're set up is that the index of each key in that sequence is based on its key value. That means index sub, I believe 27 would be for the escape key. That's only because escape is defined as 27. Now, of course, we have all these keys defined by PyGame itself, so we simply look for specific indices within this sequence to see if certain keys are pressed. The actual values held within this keys sequence are booleans. So basically, if that index is true, then that key is pressed. So now I can set up a series of checks to see which keys are pressed and look for specific ones. The first that I'm going to look at, and just a quick explanation of the keys I'm going to use, I'll use one keyboard for both players' input. I'll use the W and S keys to control the player 1's motion up and down, and then the arrow up and down keys to control player 2's up and down.
Okay.
That means the first key we're looking for here is the W key. So the check is if key index pygame.k, capital K, underscore lowercase w, then we'll do the following, because again, that being a boolean means we can simply check that as an expression itself, and if that value is true, then the W key is currently at this moment in time held down, and that means we want to cause the player to move down. So we'll say player1 dot velocity dot y will equal negative paddle speed.
Because you want him to go up.
Exactly. Since the W key is above S, that will move in the upwards direction. Upwards, in this case, is a value of negative Y, so negative paddle speed.
Because Y will be decrementing.
As a matter of fact, we'll handle that here in just a second. The next check we can do, actually I'm pausing just for a minute to see if we should check this. Let me get down working, because right now the player is at the top of the screen. If our player's code, the class code, is working, it can't go above the top of the screen, so I'll need to be able to put down in. No, I take that back. I was thinking of the way it was a minute ago. We're centered now. We can go either way. So before I do this, I was going wrestling with my own brain to decide whether or not I should check this. Let's see what we've got so far. If we run, we actually get an error. I probably didn't type keys or key instead of key. If we jump to that error, I did indeed use the word key instead of keys, so fix that syntax error. And now at the moment, we're not moving either, and there's a good reason why. We're moving the ball. Let's go take a look at update. We're moving the ball here, and I have not yet put in any code to cause the players to move. So here, and to speed this up, I can just copy the line where we're moving the ball, and right off the bat I'll paste it twice. We'll get both players set up to be able to move. So we'll take player 1, set it to move, but we want it to move based on player1.velocity, again times time factor here. And we're also looking at player2.move time by player 2's velocity. So now if we run, instance has no opposite. Okay, this is interesting. We're actually getting what looks like to be an error inside of the class itself. Let me seek to that position here. And this looks like a misspelling of position. And there we go. And now we can move up, but there's one problem with moving up now. Let me run again and I'll explain what's going on.
It just keeps...
What I'm going to do is tap the W.
Tap it, yeah.
I'm going to tap the W key, and the paddle continues to move even when the key is not pressed.
So it holds that value.
So it's exactly. So what has happened here is that if we look in the update methods, we'll scroll down a little bit. Here is update.
Okay.
So we're setting velocity Y to be negative paddle speed, to be up. Nothing ever unsets this.
Right.
And that's why I put that set 0 function to the vector and make it very easy to zero out vectors. So that means before we even bother doing anything with updates, since we know if there's no keys, we always want the paddle to stay still. The only case in which the paddle should be moving is if a key is still pressed down. So as soon as we enter the update function, we can take both players' velocity and zero it out, make sure that they stop until it is found that a key should cause them to move. So we'll first look at player 1. And we'll set its velocity equal to, or excuse me, we'll run velocity.
Right, and call on it set 0.
We'll call upon the functionality set 0, and that should zero out our vector for velocity for player 1. I'll copy and paste this line so we can do the same thing to player 2.
Cool.
And now if we run, we can move up in small increments. If I just tap the key, we get a little bit. If I hold the key, we slide to the top of the screen.
Nice.
Of course, I don't have the down key put in yet, so I can't move down from that position. But that is the desired effect for the input. So, next thing I'm going to do is, let's copy and paste this line so I can do a further check to see if the S key is pressed. If it is indeed pressed, that will allow us to move down. So I'll simply move in positive paddle speed and Y. So now you can see we can move up and down. And there's only one thing I don't like about doing this. It makes it so that the keys have a priority. Since the S key check comes afterwards, if I hold up and then press down, I start moving down. So just tapping the down key now causes it to move up and down. I'd rather have the keys almost able to fight against each other. So if you press both, they would cancel each other out. And to do that, knowing that I'm always starting at a value of 0, I could simply increment by paddle speed instead of setting it directly. That means I could do something like velocity.y minus equals player speed instead of equals negative player speed, and velocity.y plus equals player speed. Because again, every update we always start at 0, and then we go, if this was set to a value, or the key was down, then we'll increment by it. The cool thing is if both keys were down, we decrement and then increment and cancel each other out. So the effect here is we can go up, we can still go down, but if we press both keys, so now I'm pressing both, then we stop moving. So releasing up causes down, releasing down causes up. So
nice.
It gives a much nicer, more tactile feel to the feedback to not have the keys overriding each other, but instead feel like they have the same priority. So that's working very well for player 1. Let's copy both of these checks and apply them to player 2. Now the keys we're looking for here are the up and down keys. So K underscore up will be the arrow up key, and for that case we'll make sure that player 2 moves in the up direction. For the key K underscore down, the down key, we'll make sure that player 2 moves down. So once again we'll run and make sure that player 2 is able to move under the same rules, where both keys pressed causes the paddle to stop. So we have equal priority on the up and down directions. And one final check, I'm going to go all the way to the top and bottom of the screen for the players, and make sure that the players, the code in the player class is functioning properly, locking our player paddles on screen.
Very nice.
So, one thing still remains dealing with players, and that is, now that we have the ball class in place and working, and now that we have the player class in place and working, we can now do player-to-ball collision checks, and that is have the ball reflected off of the paddles if it hits one. And to be able to do that, we need to do a collision check and see if the ball has hit either of the players, either of the paddles. So we'll do this check right after we move everything. We'll jump down and we'll do a few checks to see if we've hit the player 1 or player 2. So first of these checks will be to see if we have collided with player 1. And what we're going to do here is we're going to leverage the fact that the PyGame rectangle type has a collide rect method, which allows you to feed two rectangles, and it will return true or false depending on whether or not those two are intersecting or colliding. So the check is if PyGame.rect.collide rect for two rectangles. Those rectangles will be the ball's rectangle and the player's rectangle. Of course, screen rectangles can be gathered from the getBounds method. So we have ball.getBounds as the first rectangle, and we have player1.getBounds as the second rectangle. And if that check comes up true, then the ball has just collided with player 1, the player that is on the left. So that means we need to send the ball bouncing back in the right direction. So just like we had done with top and bottom bouncing, what we'll do is we'll set the ball's velocity x to make sure that it's positive, since positive x represents moving in the direction to the right on the screen. So let's look at ball.velocity with an O.
Back one, V-E-L-O. There we go.
There we go. So ball.velocity.x will be set to the value of math.floating absolute of whatever the current ball.velocity.x is. And let's see. And the next thing we'll do is we'll check the other paddle. I'll hold off on the spin
Okay.
momentum calculation until we have both of the checks in place.
Okay.
So we can do an else if. As a matter of fact, I'm going to copy all of this code since it's going to be almost an identical check, only this time we're going to feed in player 2 for the bounds, and if this check comes up true, we want to go in the other direction. Since player 2 is on the right, ball should now move to the left. Left is negative x, so we'll negate the result of math.absolute for ball.velocity.x. And I do want to make sure that this is in else if.
Okay.
Because it's just logically thinking there's no way the ball could collide with both players at the same time.
Mm-hmm.
So with that, we can go ahead and check, make sure that this is in fact working. So now the game should be somewhat playable. And check it out, the player 1 collision has worked, player 2 collision has worked, but now there's very little skill to the game since the ball starts out moving relatively slow, and even if you hit the ball with a moving paddle, no changes made other than the bounce itself.
Okay.
So what we're going to do is we're going to get a percentage of the ball's or the paddle's own velocity and impart that to the ball. So what we'll do here is we'll first focus on the collision with the with player 1. Right after we have reflected its velocity, we'll also impart some velocity to it. We'll take the ball's velocity x. Let me correct the spelling there real quick. And we'll increment that. So we'll actually add to its velocity. And well, okay, that's another good point. What direction do the paddles move in? They move in up and down. X. They move in y. So we want to add y onto it, not x.
Yeah.
And that'll make the correct visual result.
That's right.
So we'll increment by player 1 dot velocity and dot y multiplied by the spin percentage, because I don't want to pick up all that the paddle is moving, otherwise it'll look like the ball kind of sticks to it for half a second and gets rethrown by the paddle. Instead, it's only going to be given by a percentage, and we have a variable called spin percent that we defined in the game settings. So we can multiply this velocity by spin percent, and that will take care of reducing that for us, because I think at the moment spin percent is set to a value of 0.5.
Okay.
And now we can copy and paste that line in the case of the other player's collision, only we want to make sure we're looking at player 2's velocity now. So now if we run and hit the ball, we get a crash. And already we can see in the error, I tried to spell velocity with an X, which is certainly not going to work very well. So minor spelling aside, let's try that again. And there, now by hitting the ball with a moving paddle, I can impart velocity to it, and I'll miss that there. Even.
And spelled, yeah.
Oh, it's good we're testing then. Because you will note, due to the interpreted nature of Python, errors like this don't show up until you try to hit it.
Right.
The interpreter simply doesn't care about this line until it suddenly becomes a problem and velocity doesn't exist.
Right.
All right, so impart some velocity.
Nice.
Let me see if I can catch the... this will be tricky. There we go. I hit it with the other direction, so I basically undid what I just done with the first battle. I had sped it up in the up direction, but then took that back off by hitting in the other direction. So if I want to try to impart more velocity, there we go, now twice as much, and so on.
Excellent.
So now the game, if you keep hitting the ball in the desired direction, it gets very challenging. You can get to the point now where the ball exceeds how fast the paddle was going. Notice what I did just there. I'm glad that happened, because that's a little harder to do. What just happened with that sudden acceleration is I hit the ball with the paddle after the ball had already started to go off screen. I mean, it got to where it would have been several pixels into the paddle. And I moved the paddle up and on top of it. So that meant if it didn't move completely out of the paddle in one tick, it would continue to get velocity applied to it every single tick that it was still stuck in the paddle. This means, for one, it's very good that we're using an absolute to calculate its velocity, because that way if it doesn't escape the first time, it still has as many times as it needs to escape. The cool thing about that is every time it needs another pixel to escape, more velocity gets imparted to it, which is actually a rather cool effect because you've just directly slammed it. It's a direct shot, not a glancing shot. So in the end, the effect works out very well.
Very nice.
And
that's pretty much it.
Yes, with that, that'll bring this video to a close. Again, the whole point here was to get the player class in place. With that allowed us to create 2 instances of player for player 1 and 2. And with those players, we also handled keyboard input to make sure that the current key state was used to drive the paddles. And after that, we looked at collision detection between the paddle and the ball.
All right. And with that will wrap up this video. Thanks a lot.